Okay, let's answer this question under circuit analysis, or is a current electricity. Let's use the diagram above to calculate the current I and the potential difference V across the parallel resistors. So we should calculate this current here, labeled I, that flows in and flows out here, and then calculate the potential difference, that the voltage across this parallel resistor, resistor 6 parallel 4, resistor 6 ohms parallel 4 ohms, to calculate the voltage across them. So we have two things to determine. So let's get into work. Now, before for us to calculate the current, this current I here means the total current drawn from this cell or this battery, the total current drawn. So for us to know the total current drawn from Ohm's law, which means equivalent voltage or total voltage in the circuit equals to total current R equivalent times equivalent resistance. So the current there, which is the total current equivalent, will be V equivalent divided by R equivalent. So that will give us this current I. And the V equivalent total voltage is the voltage generated by the cell, which is 12 volts. So we have our V equivalent to be what? 12 volts. So what is our R equivalent? That we have to determine. So R equivalent, which means total resistance, will be, you see these two resistors, they are in parallel. So for two resistors that are in parallel, if you analyze them, that will be 6 times 4 divided by 6 plus 4. So these two ones are in parallel, but in a combined manner, they are in series with 10 ohm resistor. So this will be 6 parallel 4 ohms, you in bracket, then outside the bracket plus 10 ohms. So plus 10, that will give us the equivalent resistance. So we calculate, this will be 24 divided by 10 plus 10. So if you do this will be 24 plus 100 divided by, did I say 24 plus 100? Okay, let me not be too quick to do things. So let me take it slow. So here divide 5, 2 divide here 12. So 5 will divide 12, 2 times remainder 2 over 5, that will be 2.4. Then plus 10, that will give us 12.4 ohms. So the equivalent resistance is 12.4 ohms. But that's not what we were being asked. We were asked for current. So this current here now, I, which is the same thing as equivalent current, total current drawn, which is now equivalent voltage divided by equivalent resistance. So equivalent voltage is 12 divided by equivalent resistance, which is 12.4, which is 12.4. So if you do this division, you will have 0.9677 recurring, or 0.9677 amps. Approximately, if you approximate that to two decimal place, that would be 0.97 amps. So that's option B. Is there any other 0.97 amps here? No. So if I were anyone writing this exam, I wouldn't waste my time calculating for the voltage since there is no other option that has the same answer as my current. So I would have gone for option B. I would have gone for option B. However, for the sake of this tutorial class, I'll still need to calculate for V so that we see how the answer is 2.3. So we see how the answer is 2.3. So now to calculate the V there, the voltage V will be what? The current through that branch times the resistance. So if I label the first resistor here, the 4 ohms resistor R1, and label the 6 ohm resistor R2, so V here will be I, this current through them, times R12. That's R12, that's the equivalent. R12 represent the equivalent resistance of these two that are in parallel. So this will be, our current is 0.9677. The reason I go back to this other one, I left approximated one, is to minimize error. To minimize error due to approximation or approximation error. Then times our R. What is our R? Our R will be 6 times 4 divided by 6 plus 4. So that will be equals to 0.9677 times 12, or 12 over 5. We already did something similar there. So if you do this multiplication, if you do that multiplication, you'll be having 2 point, I mean 2.3225, 2.3225 volts. If you approximate that, that will give you 2.3 volts. So therefore, our current is what? 0.97 amps, while our voltage, which is here, is 2.3 volts. So that is how this thing is done. So you like, share, subscribe, and then if you need a one-on-one online tutorial in real time, you can contact me through the link in the WhatsApp group. I mean, through the link in the description. The link in the description will take you to my WhatsApp group. Say then we make schedule on how to do the online class. So that is it. Thank you very much.